Hey everyone, welcome back to the channel Code with AKJ. So today is day level of solving LeetCode 75 challenge, and today is our second question from two pointers method. So today's question is subsequence. So the question says given two strings S and T, return true if S is a subsequence of T or false otherwise. And here a subsequence of a string is a new string that is formed from the original string by deleting some characters without disturbing the relative position of the remaining characters. And given examples here, string S ABC and string T AH BGDC, and we need to find whether S is a subsequence of T string or not. So to be a subsequence of a given string, each and every character of that target string should be present in a T string. You can observe that in second example where string S is AXC, and we can observe that X character is not present in string T, so we can return false from there itself, that string S is not a subsequence of T. So let's move on to our brute force approach. So our initial thoughts would be to generate all the subsequence of string T here, and we need to check for each and every subsequence whether it matches with our string S or not. It generally takes exponential time complexity to generate all the subsequence. Overall time complexity here would be O of 2 power n, where n is the size of the string T. And space complexity here would be O of 1. So however, let's try to code that approach and submit. So here's the code for the brute force approach we have discussed, where we generate each and every subsequence of string T and we'll check whether that particular subsequence is matching with our string S or not. So to generate a subsequence of a given string, we'll use our include exclude method, where we try to include a particular character into our string or exclude that current character into our current string. So in this way, we use two functions to either include a character into our current string or exclude that character into our current string. And finally, whenever our index reaches at the end size of our string T, we'll check that current string matches with our string S or not. So if it matches, then we can say that S is a subsequence of string T, or if not, we can say that S is not a subsequence of string T. So here the time complexity would be O of 2 power n, where n is the size of our string T and space complexity is O of 1. So let's try to submit this code. As you can see, this approach gives us memory limit exceeded, which is highly inefficient for any kind of string. So let's try to improvise this code and our approach. So in our optimal approach, we'll try to use our two pointers method, where we use two pointers. One is I and one is J for both our strings S and T respectively. And we'll try to match those indices characters with each other. And if it matches, we'll try to move on with our next characters to match each and every character of S in our string T. So finally, if our I pointer, which generally iterates over our string S, reaches the end of our string S, then it means we have found each and every character of S in our string T, and we can directly return true from there, and we can conclude that string S is a subsequence of string T. So let's try to understand our optimal approach, where we are using two pointers approach, I and J. So here we'll take both two pointers, I, which iterates over our string S, and J, which iterates over our string T. So we'll try to match these two indices characters, and if I pointer reaches at the end of our string S, then it means S is a subsequence of T. So let's try to dry run using this example. So initially these two character matches, so we'll try to move this pointer to our next character. J moves to the next character, and since they are not matching, J moves to the next character. And here, since these two characters matches, we'll move pointer I, and J moves to the next character. And since these two characters are not matching, we'll move our J pointer to next character. And same goes with D. Since they are not matching, we'll move our J pointer. And since these two pointers now are matching, we'll move our I pointer. So here our I pointer moves out of the size of our string S. So from here we can conclude that string S is a subsequence of string T. So let's try to take another example where S is A, X, C and T is A, H, B, G, D, C. Again, we'll take two pointers I and J. Here they both are matching, so we'll move I pointer to next character and J pointer to next character. And from this we can see that these two characters are not matching. We'll move our J pointers to next character. And while comparing to each and every character, we can see that J pointer is moved out of the size of our string T, and we didn't found any character matching with X. So from this we can say that string S is not a subsequence of string T. So in this way, using 2 pointers, we have optimized our approach and we have found the way of finding string S is a subsequence of string T or not. So let's try to code this approach and let's finally analyze our time complexity and space complexity. So here's the code for our problem using 2 pointers approach. Here I've taken I and j pointers, one for string S and one for string T, and we have traversed over both strings. And if there's a match, we'll increment our I pointer, and if not, we'll always move j pointer in string T. And finally, after finishing our while loop, we'll check whether I reaches the end of S. And if it reaches, it means all characters are matched in string T, and we return true. And if not, we'll return false based on this condition. So let's try to run this code. So let's submit. As you can see, this approach is successfully submitted. So here the time complexity would be O of n plus m, where n is the size of string S and m is the size of string T. And space complexity here is O of 1. So let's try to analyze time and space complexity of both approaches we have discussed. So for the brute force approach, the time complexity was 2 power n and space complexity of O of 1. And for our optimal approach, the time complexity is n plus m and space complexity is O of 1. So in this way, we have optimized our time complexity from exponential to the linear. So that's it, folks. We have explored this is subsequence problem starting from a simple brute force to a highly optimized approach. So if you enjoyed this walkthrough, don't forget to like, subscribe and hit that notification bell. Drop your questions in the comments and I'll see you in the next one. Thank you.